Okay. This is wait a minute. Why is it projecting? HDMI. Okay. So I would like to go through an example about how you should use exception when you together with inheritance, particularly to do with multiple inheritance. You have to be careful about exactly what kind of things to add to that. So so this is the code that's actually I update a little bit. It's ecs36b exception. H. Okay, if you take a look at this code, I basically list all the different cases that you can actually put it in. You can see that the first 4 cases, if you actually declare that way, it will work. So let me actually clarify. What do I mean it will work? It won't work. This is the thing is interesting about this perspective is that when I say this will work or won't work is actually at runtime. So any of this 8 statement, I mean, they're probably all alternative that you can do. They all pass compiler. So the compiler will think that you're writing a great code. No problem. The compiler let you go with any of this option. But at runtime, some of them will be able to catch the exception you try to catch. But some of them, when you have this kind of property that the exception won't be able to call. So whether you can catch exception is actually mostly a runtime concept. It's not a compiler type concept. It's compiler has no way to know which one you intended to catch what. Because typically is some piece of code written by somebody else. And you don't know what kind of exception that particular piece of code is going to generate. You only might be able to get a look at the document, but in general, the program, when you include a file, or when you link to a library, you have no idea what kind of exception will be spit out. And well, in terms of as a programmer, this is a good lesson to learn. When you want to use somebody else's code, what you want to do is that you want to get ready to catch a broad range of exception. And then with that, then essentially, if they actually throw something, then you have the right clause. So let me actually show you, before I went into this example, I want to show you a example extended a little bit compared to what I have for you on Monday. So if you look at, I think it's called test. This is what, bad alloc. Wait a minute, what is bad alloc? Hold on. What's the program name? It's called bad alloc test, sorry. So I have actually 2 programs. One is called bad alloc tests and bad alloc test 2. So let's actually take a look at the program I showed you earlier. So in this program that I actually put a try clause and try to see if there is any kind of memory allocation problem. And when I try to catch it, I actually use this generic exception. This is the base class for all the system or whatever application related to exception. I was talking about this particular figure. If some of you might still remember. Let me see. Let me show you. This is an important figure. Right. This is a figure I'm talking about. That is a main message you should get. So when you have this to get out of this. So you can see that this is STD colon exception, which is the most commonly used exception we try to catch. And the thing is, under there, all this are derived class. So for example, the particular example we talk about is STD bed underscore alloc, which is the memory when you do malloc or free, or when you new and delete, and those kind of things will get triggered. So think about this. This is a derived class. This is the base class. So when you look at this example, I want to catch, I mean, there are two ways I can do this. I mean, one way I can do this is I just simply modify this code here. If I know precisely what I'm trying to catch, I can actually just change this to bed alloc. Okay, I can actually just do like this. And then I should be able to catch the bed alloc. But the thing is that this catch clause becomes so narrow. It can only handle that particular derived class. So in general, if you want to be broader, then we basically say exception. We basically put the base class, because if you actually catch the base, then any of the derived, it will be catched by this as well. Okay, because it's more general, you can handle that. Okay, so that is what I show you. Just let me just run this program very quickly, just refresh the memory a little bit. Minus STT is equal to C++ 14, and then bet.alloc.cpp. Okay, I compile, and then I do a.out. If I do 2000, no problem. If I do add a few more zero, that you can see that now I'm actually getting this exceptional handling. The three lines, the last line represent the class. I'm using the type ID to actually see exactly what derived class that's actually generating for this particular exception. Okay, so this gives the application programmer some extra information about, once you got this, then what you're going to do about this, and then whether you want to do something or try to shut down your application program gracefully. That's your choice. Okay, but that is exactly why we want to do that. So I wanted to show you what's the difference between the first one and the second one. So the second program, I want to show you the program first. So the second program, I'm actually using the ecs36b exception.h. So what is that? That was actually here. That was, I'm talking about multiple case of the inheritance. I'm actually going to use this case. So I'm using the first line, which is a valid way of doing inheritance. So you can see that that is a derived exception that we create, and is directly inherited from exception. Okay, based on that, so now I want to ask you, this is pretty much the same code as the previous line, previous file. But what I did is I actually did this. You see that I'm actually have a try a bunch of things. And then I said, when I catch ecs36b underscore exception. Instead of saying the previous version in betalloc test.cpp, it was exception and E. But now I'm actually using the new class I just created. So my first question to you is that if I decide to do this, if I do this, try to catch this way, do you think I can catch the betalloc exception like the previous case? Yes or no? So let's try it. I mean, usually when I ask this question or you ask this question yourself, the immediate answer is that let's write the program. Let's run the program, because really sometimes you get surprised to understand your misunderstanding, whatever. I'm going to first block out this part of code. Okay, so you can see that I'm trying to allocate the memory, and then I try to catch with ecs36b underscore exception E. So let's actually try to run it, compile it. Whatever number, that's actually huge, this number. Okay, now you actually see that it's not that particular routine cannot catch the one that was thrown. So if you look at the error message, that this is a important message, you know that if you see this kind of message, that means your exception handling whatever catch, whatever clause you made, mismatched with the program you try to receive those exceptions. So there is a mismatch about the expectation. So you can see that this line basically say, by the way, the application program will abort. Because why? Because anytime you throw an exception from either your own code or somebody else's code you're using or linking, and you didn't catch it, that's immediately trap number 6. And then it will display a message saying terminating due to uncaught exception of type std alloc. So essentially saying that, wait a minute, I tried to catch ecs36b exception, but this std alloc, they are actually a different type. They mismatch with, because both ecs36b exception and std, alloc, they are actually under the base class exception. So that's why earlier, if I try to catch with exception, I will be able to get it. But if you try to develop your own exception, then some of the system exception will not be catched. Then your program will actually go into this kind of undesirable behavior. Because whenever your application program had this, then essentially the whole program will be shut down into whatever reset mode or something like that. Okay, so how do I actually fix this problem? The way to fix this problem is like what I did here. I actually have 2 catch clause here. So I actually have a 2 catch clause. So this clause is actually going to catch this one will catch all the system one, but that one will catch specifically that I actually want to customize. Okay, so this is actually a good thing. So whenever there is a exception generate inside that try clause, even from somebody else's code, the nice thing is that it will first see that which one is more specific for that particular exception. So essentially saying that, well, if I have 2 of this, regardless of their order, if that actually match ecs36b exception better, it will actually prefer to invoke the first catch clause instead of the second one. Let's actually try this one first. Let me just show you that you can write a program and see to verify whatever we discuss in this class. So you see that I actually switched their order. I put the default over there. And over here, take a look at what I did here. Let's actually add this line. I said I throw a ecs36b exception. I'm actually throwing that a more specific derived exception class. So if I try to run this program, and if I do this, just 20, okay, now you can see that because this program does not trigger, the M size is only 20. That means I'm not creating the bit alloc. So essentially it's going to trigger the line. I'm going to generate a ecs36b exception. And then I have 2 clauses. One is exception, one is ecs36b exception. And you can see that the one that actually caught that particular throw is actually the second one, which is the ecs36b. Okay, on the other hand, let me see if I actually add a bunch of zero. Now this, you can see that now it's actually being caught. The first one, the M size is so big, and then it basically caught the standard one. So if by using this kind of two catch clause to actually handle all kinds of situation that you can handle, then basically you will be able to catch both your customized version of exception and also be able to catch the standard exception. So it's always good. By the way, this is my advice to all the programmer running exceptional handling is that if you want to do exception handling, always include this part. Always include this part because that's going to catch. Yes. Uh-huh. You know what? Did I actually change this? I might have to change this. Probably not standard exception. Let me try to run it. Maybe I forgot to type it. Let's try to run the program again. So if I do this, this is going to be the that's the standard exception. Is that right? Is this what you're bothering you? This one, right? I think you're right. I think you're right. That's interesting. I didn't pay attention. It's actually catched by. I think you're right. It's actually still going through the first one, right? That's actually bad, actually. Let me try it this way. Okay. All right, you're right. Thank you. So I was purposely made a mistake to make sure some of you are not sleeping. Of course, I'm joking. I actually I was wrong, and I think that sometimes I feel I know these things, but unless I actually write the program to try it out, I actually sometimes have surprise. Okay, so I think what's your name? Jim. Jim's. So James basically say that if you have multiple class, it's actually followed by the order. So I still need to actually verify why this is this way. That is doesn't look natural to me about matching the more specific one. But essentially saying that if I throw something, I will go down the list. Whatever exception, the catch, the type is either the same type or is one of the base type to that particular things you throw, then it will catch it. So it's basically one by one go through that. That's actually interesting. I didn't pay attention to that because I always put that one first. So if you switch order of this two, the result actually will be different. Okay. Yeah, that's actually very interesting. It's the design. I'm not trying to judge whether it's a good design or it's some kind of a bit odd about how they designed it this way. Okay. All right. Good. So as a programmer, now I adjust. So you want to put the exception, which is the general one, the latest. And you want to put your own customized earlier, so you will be able to catch the right one. Okay, any question? Great. Okay, so once we actually know this part, now we go back to our previous example. Now we can take a look at our ecs36b. Okay, now I'm actually giving you, to save time, I'm not going to run each of the case. You can actually run this program yourself. So let me just run one case of each so you can see what's the difference. So this one, the current line I have, this one is actually from this line, actually, from the second line of the first case. Okay, the second line of the first case. These two are the same, so let's actually try to run it. And then I'm going to run the server. Sorry, this must be here. Running the server, and then I'm running the mobility dump, which will trigger the exception. So now you see that it's actually printing ecs36b because it actually generated an exception, and that one catch that. Okay, so if I modify this, to, let's say, second line, whatever. If I modify this, you can see compiler doesn't even bother to give me any warning when I try to do this. And let me try to, I actually don't need to even, you see that when I try to run it, my server is here, still running. And now I'm actually getting the abort trap 6. The same program, except the order or except some of the things. I mean, I want you, it's not necessarily related to order, by the way. It's related to the way I actually declare the relationship in the multiple inheritance. So I show you two cases. Compiler, no problem. But at runtime, one will be able to catch. The other one won't be able to catch. So we need to find out exactly what's going on. So let me actually look at the code again. I better actually change this back, because then I will. So in the program in the GitHub, I actually gave you 8 cases. Okay, the top 4 cases, they all work fine. The next 4 cases, they will all not be able to catch the clause that we want to catch. So now my question for you is that why, based on this 8 cases, those 4, those work and those didn't work? And can you actually tell what's the difference between the first group and the second group? Yes.
The second group, well, for the first 2 lines, it doesn't have a public specifier.
Yes.
So I think it defaults to private, or I don't know.
Yes. Yeah, the key issue here is public. Have you noticed that it doesn't matter how you do it, but when you inheriting from STD exception, in front of the STD exception, you must have a public. In order for you to actually be able to catch a system or whatever exception, which is generated by the standard, you have to have that public. If it's not public, then you essentially make the whole class become private during the inheritance relationship, and then such that the exception become unable to catch anything. Okay, so you can see that over here. So I made a mistake. By the way, I still make the mistake sometime. Let me ask you, if I actually define it this way, what's the, let me actually say, do you think those two are the same? Let me actually give you 2 lines. This 2 line, you think they're the same? You think they're the same? They're different. Just want to tell you they're different. So if you define something in C or C++ syntax, you can say integer I and j, right? And so you can give a type, and then that basically apply to all the variable after that. That's just type. Or you can say integer star. Let me give you another interesting point. Interesting. If it's this x, y. So is this star apply only to the first variable or both variable? That's a pointer syntax. I'm not even sure about that one. I have to write the program to try. But my understanding, my guess is that when you say integer ij, it's applied to both. But when you say integer star x, this star only apply to x, doesn't apply to y. It's my understanding. So the star should actually go with the variable like here, not go with the type. Okay, so that is just a little. So this case, these two are different because the first one, in fact, this is private. It's implicitly, if you didn't say anything, is private. This is equivalent to that one. But if you want to actually doing multiple inheritance and the STD exception, if this is why this one won't work. This is why this won't work, because if you have a public ecs36b special and you forgot to add the public in front of STD exception, this one compiler will feel okay. But at runtime, this one won't be able to catch the exception you want to catch. So if you change that to this way, then it works. You add a public to both sides, it works. Okay. Okay, I hope this will give you some interesting perspective about the syntax of the programming and how you should write your code and such that you can exactly catch the, because the thing is that exceptional handling, unless you really run some test program at runtime, otherwise you don't know whether that particular exceptional handling code really work or not. Okay, the compiler won't actually be able to give you that kind of information. Okay, so I hope that give you some idea. Now let me actually continue with the still exceptional handling. I want to give you a little bit more in this topic. Okay, so I'm going to actually having another function, another definition I call trouble. Okay, this is the way that you can actually create. This is not even inheriting from exception. It's just I want to create something called trouble. You can think about that as an exception. This example, I think, from your textbook. So you can take a look at what I defined here is that I just defined the constructor to allow me to actually put a message which whatever problem you want to put in there. And there is a problem. This is the default message that you're going to put it in, okay, for the constructor. And then you just print out this. So if you want to run this program this way, this is, by the way, chapter 15 of your textbook. You can see that I actually I can throw trouble without any parameter, which means that you're going to pick up that this is the problem as a default parameter. And then, or you actually can do whatever you want over here. And then this basically, depending on the value of I, is actually going to call the trouble. And then, but the output is going to be somewhat different. Okay. All right. That's the example. Now we're going to see another example, which you might have seen. This is actually from homework assignment. Maybe homework assignment number 0, one of participation code. Okay, so let's actually take a look at this code. This is also a exception. Let me make it a little bit so I can show you the whole thing. Okay, this one was actually generated by JSON RPC stuff. So the thing is that JSON RPC stuff is very smart. They actually generate all the code together and such that it will be able to automatically take care of all the exceptional handling. Okay, and take a look at what they define. They actually define a class. The next page, they define a class called JSON RPC exception. So why is JSON RPC exception? If you take a look at here, I actually try when you're handling one of the function within the JSON RPC, is actually going to throw, and when they throw, they actually throw JSON RPC : JSON RPC exception. And what is JSON RPC exception? Is actually just like what we did, is inheriting from STD exception. So it's over here just like that. The only difference is that they actually define with two variables. So this is something which is really nice for the exceptional handling, because when I actually generate this object, I not only include the error code, but also I actually include the JSON string itself. So you actually receive two parameters. The first parameter is an error code. The second parameter is essentially a string representation of JSON. So you can see that they're just basically to style string. So they put a string. So they actually throw this two at us as a standard library. Okay, and then you can see that this is basically the code is encoding. They actually put whatever you input to this function, they encode it into a JSON, which that JSON is actually result. So what is the result? Is all the variable you receive through the JSON RPC process, and then they just throw that into this. And if you take a look over here, that this is the interface. It's very similar to the STD exception, except I actually have, when you throw the message, you can see that the third line is what we're talking about. It's basically throw a string of message, or you can actually, by the way, you can actually throw a code and the string message, like what we did is to style string. But this actually has an interface that you can throw the code and the message, and you can actually throw the original JSON value as well. So you can have multiple interface, which is allow you to be able to record all the information. And when you do what, is basically help you to encode all that information as well. Okay, so that is essentially the interface that you can set what, you can set get code, you can set get message, or you can set get data, those three functions. So this is a good example I like, because it shows you that how you can design a more informative interface for exception to include all kind of information you want to communicate, such that if I write a server, I will tell you that why you actually send me a JSON and which part of that is actually incorrect. And then you can actually design some way it looks like this, and such that you can actually pinpoint exactly what's going wrong. Okay. All right, so now I want to give you the last part of the exception. I hope do you have any question before I talk about segmentation form? Okay, so the last part I want to talk about, let me see, I have all the test program went through, I think. Okay, so I have a program here called segfor. Where's the segfor? Okay, segfor test.cpp, okay. So let's actually take a look at segfor. So this segfor CPP, if you take a look at this, I just try to dereference a null pointer, and I try to catch with the standard exception. So I want to see if somebody make an error like a segmentation fault, will I be able to catch it? Okay, so let's actually take a look at this. G++ minus std is equal to C++ 14 segfor test.cpp. If I do a.out, okay, the answer is I will get segmentation fault, and this piece of code won't be able to catch it. Okay, so lesson number one, if a segmentation fault is out of the capability of exception handling, okay, because it's not really your program. Yeah. Segmentation fault is an exception, but it's not an exception that exceptional handling in C++ can handle. So all the C++ can handle is over here. This are all the standard STD exception that you can handle as a programming language. So it's a programming language as application. You can handle all this related to the programming language. Some of the error that you can handle, but not segmentation fault. Because segmentation fault, when that happens, you already go to the violation against operating system, not against your application program. So it's not really a programming issue, is you actually violate the operating system policy. So that's why segmentation fault is not something exceptional can handle. However, there is a way to catch it, but not using exception. So that's why I want to show you this piece of code. So now I want to show you another piece of code, which is also included, is 2. That's 2. Okay, good. If I do this, now I said, you see that I'm actually caught the seg fault and address, whatever. Okay, I actually caught it, but I'm actually caught it using a different way, not an exceptional handler. Let's take a look how I actually caught the code. This is some of the extreme example. I'm not recommend you do this all the time because it's potentially you're against the operating system and it will be trouble. Okay, so I actually tell you that this piece of code, I got it from that Stack Overflow link. Okay, so it's not my code. Somebody developed this code, but the principle in general is the same. So in order to catch that, so segmentation fault is related to the signal that we receive from the operating system or from the hardware about some of the prohibited condition that has been violated. And therefore, for me to do that, I have to catch that. I have to redirect that signal to my own program, then I can handle that. So you can see that I actually write a function, I call a segfault, segaction. And inside that function, I have to give that parameter, 3 parameter, integer signal, seginfo t, and whatever, those 3 parameter for me to catch it. And inside there, I basically say, hey, I call segmentation fault at whatever address, okay? And that address is actually provided by SI, that seginfo t. And so let me actually tell you that the first part is more or less the same. Okay, the first part is more or less the same. Integer foo, I actually set a pointer, the value to be 256. I mean, you can change this to 0, but you can change this to 0, and the data might be a little bit different because remember I tell you the first 1K page, if your address is actually less than 1K, is always segmentation fault. 0, 1, 2, 3, 4 is all segmentation fault because the first virtual page has been reserved for this purpose. Okay, so okay, you set the address, and then the way I actually will work is this is the following code is the code I showed you earlier because I try to set the value 1 into the area pointing at foo. So this is a dereference. Star foo is equal to 1. And foo is actually an address that's prohibited by the operating system. So this line is actually going to cause a segmentation fault. So what I did in this part of the code is basically set up so I can actually redirect the signal. So this is really a C programming issue. It's nothing to do with C++. It's a Unix related issue. You can see that I just create a data structure called SIG action, which is SA. I create that action, and then I basically reset memory, set it up, and then I set the mask itself. I empty the mask first. And then what I did is that this is important. I said, whenever you take an action, the SIG action, I actually insert here. Anybody know what this is? This is a function pointer. So this SA SIG action is a function pointer, and I put sig_for SIG action. Where is that? That is this function. So essentially, I set the function pointer into that SIG action data structure. Whenever there is a sig_for, you will not call the whatever default handler. You're going to call this function. So in this way, I can actually catch segmentation fault. Okay, so the final step you need to do is I actually set the flag to be SIG info, and then basically this line is actually put things in action. I call this function called SIG, the system call called SIG action. Whenever you have SIG segmentation fault, SIG_FEGB, this is signal for segmentation fault. I basically say whenever you have a segmentation fault, using this SA as the handler, as I just created, and you set the value. So let me just summarize what you did. First, you actually create a data structure called SIG action. And second, you set the function pointer for your own handler, which is related to a catch clause, as a function pointer into that data structure. And finally, you bind your own SIG action data structure with this particular signal. And that particular signal is sig_fault. And by doing this, whenever sig_fault happens, it will be under your control in this case. Whether it's good or bad, I don't know. But I have some real world cases. I have seen this happen in my life, but I will stop here. Okay. All right. So I will see you on Friday, your midterm. Okay. I have a quick question. Sure. Hold on. 1 second. Let me just.